Okay, anyways. So far we discussed the main components of ER modeling, like um, entities, attributes, and different types of entities and attributes. We also use ERD Plus to draw sample ER models. We talked how ER modeling is the core process in database development, in relational database development, and how that actually affect the whole process. Because if you start with a good design, like if you include all the, for example, main entities, attributes, and you correctly identify the relationship between attributes, if everything goes well on that side, then you can easily translate that into relational schema, which we cover today, and later you just have to use SQL queries to translate that into like queries, right? But the main design part is actually the ER modeling, which is, in my opinion, is the most important part. And so, what is a relational data model? Relational data model, and how can I, just to increase the class engagement, how can I see? I just lost your. Uh, I want to be able to also see the chat, just to make sure I see your questions. Yes, and because this is recorded and I'm using only one screen, just to let you know, whatever you type in the chat is going to be recorded. Just I just mentioned it for your privacy. So if you want to send me a message like private message, it will be shown to everyone. I'm sorry for that, but I'm using only one screen here. And so if you have any questions, you can mention it in the chat, or just unmute your mic, raise your hand, unmute your mic, and start to talk, which is even better, because it's a bit weird when I'm just talking here alone and then I just feel like no one is listening to me. So I appreciate if some of you at least also talk using the microphone. So I'm going to check this every once in a while. And so we said that the relational data modeling is just a way to, a logical way to show your database in terms of tables, and these tables are related. Not every two tables are related to each other, but only the tables or entities that we identified in our ER modeling, right? For example, back to the student registration example, if you recall, we mentioned, okay, we have a student entity, and we have also, for example, enrollment associative entity, and for example, course entity, right? Because a student and course have many-to-many relationship, and then we learned how to use associative entities to translate many-to-many into two one-to-many relationships. And so let me see, will you be providing some examples of project proposal in e-class? Yes, I can do that. I can post a sample today. Okay, no problem. And back to the course. So back to the lecture. So relational data modeling is just how we are now showing our database as a collection of related tables. So now we are converting or translating each entity to a new table, each attribute of entities into columns of those tables, and the links or relationship between entities are also I'm going to explain how we can show them in relational databases. Most of the time using the foreign keys, which we discussed today, and in general using a common attribute between the two entities. Now, relational data model organizes data as a set of relations. By relation, I just simply mean tables or two-dimensional tables. And recall, in the first lecture, I was discussing the difference between SQL, or for example MySQL, SQL Server, and in general the difference between a query language database and database management systems, right? Anyone recall that? Anyone can recall what was the difference between SQL, MySQL, SQL Server, and so on? Okay. Jade, do you want to unmute?
Yeah,
Okay.
I remember.
Yeah.
Did you want me to explain what?
Yeah, just the difference between SQL, SQL Server, MySQL.
Okay, I think SQL is a language, a structured query language, and MySQL is a database management system.
Yeah. So SQL is just a query language, which can be used in any of like these software packages, right? And then we have MySQL, SQL Server, SQLite, and so on. Or, for example, Oracle. These are just some of the most commonly used DBMS or database management systems, and these are examples of when we call them RDBMS. We just mean relational DBMS, which is actually the main focus of this course. And so a relation is viewed as a two-dimensional table with following properties. So we have a table, each column, I think I mentioned most of these before when I was covering ER modeling, but just to review them. Now, each column should have a unique name. So this is, I think, obvious. It doesn't make sense to have like two columns with the same name, right? So if you have one, for example, a column, a student ID, then you won't have another column, a student ID, right? So each column must have a unique name, and the order of columns is not important. It doesn't matter if you start your table with a student name, for example, first name, last name, a student number, or you started a student number, a student first name, last name. So the order doesn't matter. And in each column containing values about the same attribute, this is also clear because, for example, if your column is a student number, you expect to see a student IDs or student numbers in that column, not a student name, right? And then each row must be unique. Duplicate rows are not allowed. So when we're talking about relational data model, we want to make sure about data integrity. And what does that mean? So each record or each row of your table must represent just one instance of that entity. And that should be a unique instance. For instance, consider a student table. What does each row of a student table represent? A unique student, right? So each row or each record is belongs to a separate student. So we do not expect to see two rows uh, with the same student, right? Similar thing is for example, the course table or employee table, department table, a product table, any table that you identify in your ER model, any entity that you have, which is later translated to these tables. So all these tables, rows, the rows in those tables should be unique. Now within each row, each cell should also be single valued. I also discussed this several times just to prepare you for this session. So we want to make sure that our data is atomic, and by that I mean we cannot, for example, store information like let me be more interactive and use how can I use the writing? Should I draw? What is this one for? Okay, now this is good. So just use the pen. It's okay. So let me change the color to red, and this is good. So for example, something like this. So let's say you have a student ID here, right? And a student name, for example. So we cannot have, for example, and here is, for example, phone number, right? Imagine this is only first name or last name. So we want to have first name, last name in separate columns. But the main focus is not on this column now, it's on this. Now, let's say, for example, a student has two phone numbers, right? We cannot store them like this. Phone number one, phone number two. So you cannot separate them by commas. Or if, for example, let's say a student is enrolled in several courses, if you add course ID here, right, to show, let's say you say, I want to show for each student which courses that a student take. For example, a student ID 1, which is maybe Mona, is taking, for example, course 3421, and then, for example, 4412, and so on. So you can't show it like this, right? And we discussed this before. This is not efficient. For instance, later, there are many reasons why we cannot do this. One of them is, for example, later when you are learning how to write SQL queries, you will see that you access, for example, each, for example, you want to access specific values in tables, we mostly use, for example, access them by column names, right? For example, you want to select a specific, for example, course, and then that would be very difficult here, right? Because you already stored multiple values here. There are some ways, if you have something like that, there are some ways to retrieve like each of these separately using SQL queries, but you have to do, like, for example, text search and so on. That is not efficient. So we try our best to avoid storing multiple values in one cell, and so this is not correct, right? And this is also not correct. Now, within each row, each cell should be single valued. This is what I meant here. And ensure data is atomic. For example, each piece of information is indivisible. And this is exactly what I explained here. The sequence of the rows is not important. So the order of the rows or columns are not important. It doesn't matter if column, your table, for example, started a student ID, then a student name, or vice versa. Same thing with the rows. It doesn't matter if you start with a student ID 1 or you start with a student ID 2 or 3 and so on, right? So the order doesn't matter. And just let me open this. Okay. And now there are some okay, let me also check the chat. So would an entity of a table be its title and attribute the column names as well as its foreign key of table connecting to primary keys of another, like a student ID student table connect to student ID course table? Would an entity be its title and attributes? So each yeah, we have Kahoots. For the second question that asks about Kahoot games, depending on how much I can cover today, we may have Kahoot at the end of today's session or at the beginning of the next lecture. So about the Harit question, I didn't understand your question, I guess, but let me know if I didn't answer your question exactly. So an entity, we don't have an entity of a table. So the table that we have are representing the entities that we had in our conceptual design. So remember in the introduction, we talked about like different layers, and then we talked about different stages of database development. And then we mentioned, for example, ER modeling at stage 2. So stage 1 was just collecting requirements, defining your business rules and everything. And then based on those business rules and assumptions, for example, what is an example of business rules? A student can enroll in several courses and each course can have several students enrolled in that course, right? This is an example of one business rule. Now, after we define this is a stage 1, which you will also do for your assignment 1. Then the second step is to draw your ER model, which is your conceptual modeling, right? Now in conceptual modeling, you define, for example, what are the main entities, what are their attributes, and so on. And what is an entity? Entity is representing an object, anything, person, anything that you would like to keep information about that, or keeping data about that. So if you want to store student information, you should have a student entity, right? If you want to store, for example, product information, you should have a product entity. To keep track of payment information, you should have a payment entity, right? Now, sometimes the confusion arises when students do not know, for example, if they have to consider, for example, an object or anything as attribute or entity. So for example, phone number as a separate entity or phone number as an attribute of an entity. It depends. Sometimes it's very clear. Sometimes you have to think a little bit more. For instance, uh, if uh, if I tell you, for example, something like objects like, for example, a student, employee, departments, these are obvious that they are entities. They have clear attributes, right? For example, you have a student entity and the attributes are a student number, a student first name, last name, phone number, email, and so on. But when we say phone number, it depends. For example, when you're talking about class section, course sections, these could be represented as attributes or as entities depending on your assumptions and depending on your database. For instance, if you can define some clear attributes for something, then you can define it as an entity. So in case of, for example, classes or course sections, if these classes have their own attributes, and if they have that, then you can define them as a separate entity, which we did in the class. um, for example, each class may have a room number or may have some, for example, other information, time, schedule, and so on. So we can consider it as an entity. Then we have to decide whether it is a regular or weak entity. For example, if it doesn't have its own primary key and it depends on another entity for its existence, so both conditions should be applied. If that is the case, then that is a weak entity. For instance, course section or like classes of each course, uh, they could be weak entity or regular entity depending on how we define them and what is the case. For instance, the example I mentioned in class, I said at York we have, for instance, ECS 3421, which is a course code, right? And then because some courses are large, they have several sections. For example, ECS 3421 may have, for example, may offer 3 sections in fall term, 2 sections in winter, right? And maybe 1 section in summer. So if in general, if there was only 1 section for this course and all courses in our database had only 1 section, then it it didn't, like, you didn't have to define a separate entity for a section, right? Now we have different sections, so we need a separate entity. And because each section can have different attributes, right? For example, we can have different instructors for each section. Or for example, they may be, for example, section M may be in room, for example, LSB 105, but for example, the other section may be in another building, right? So because their attributes are different, you cannot consider them like just as an attribute of an entity, and you have to define a separate entity for them. Am I clear on this? Is this clear? Is this example clear? Okay, good. Now, um, then we say, okay, but course section, let's say section M, N, etc. What would be the primary key in that table? So we don't have any natural key, and by natural key I mean among the attributes that it has, none of them can uniquely identify each row. For instance, when I'm talking about a student table, so all the students have a student number, and a student number is a unique identifier of each student. So I can say a student number can be used as primary key because it's a unique identifier, and because no 2 students can have the same student number, right? And each row will be unique. But let's say I talk about, for example, course sections as a separate entity or table later. right? Can I say course section, for example, section M, N, A, B, C, D? So these characters, this column will be my primary key for the course section. It depends. In this case, in the specific example I mentioned, it cannot be, because uh, section M and N are not unique, right? They can be used for different courses. We can have ESS 3421 section M, or we can have 3401 section M, we can have 4412 section M, and so on. So section M has only meaning, like has meaning only when it is used with the course code, right? So you have to clearly mention, for example, ESS 3421, which is the course code, section M, to represent a unique class or a unique section, right? But if you just mention section M and A, B, C, D, it doesn't represent anything. That is why course section in my example was, I considered it as a weak entity, because first, it didn't have any like natural key that could be used as primary key. It doesn't have a unique identifier of its own. And the second reason, it depends on the course code for its existence. For instance, if we don't have it depends on the course entity for its existence. For instance, if we say section M, it doesn't have any meaning if it is not accompanied with a course name, like for example, database course or ECS 3421. Now about synonyms in this slide, when I say relational table and table, they all refer to the same thing. Um, the only thing that you have to consider is that every relation is a table, but every table is not a relation. And what do we mean by that? So, in general, when we are talking about relational tables, and we are going to see examples later today, um, it has some characteristics. For example, having atomic values, not storing multiple values in a cell, right? And so we call that a relation. But if a table doesn't have have those characteristics, it's just a table, not a relation. Row tuple records, same thing. Column attribute field, same thing. So if I say attribute column field, they are basically the same thing. And then domain is just set of possible values that we have for an attribute. Now, here's an example relation. So here I identified different types of key that we can have. Among them, I think the most important thing is identifying primary key and foreign keys in your tables, and also candidate keys. So what is a key or primary key? We repeat that many times. Oh yeah, in this example is employee number. In general, it's a unique identifier, right? And it's unique identifier of what? It should uniquely identify each column, each row, each table. A row, exactly. So it should uniquely identify each row. So for example, we only have this student employee number. The first employee number you see here, 28719. We only see this once, right, in one row. It uniquely identifies each row because it belongs to a Smith Tom, right? We may have two employees with the same name, right? But we cannot have two employees with the same employee number. That is why, for example, employee number here is not a good, for example, candidate for being a primary key, right? Because it cannot uniquely identify each row. So what if, for example, in this table, as you see, no two employee names are the same. So why do we still consider employee number as primary key, and why? Or is employee number, can we, for example, assign employee name as primary key here because it is also unique? No, because on those terms, someone has the same name as the other. Yeah, even if we don't have same name now, we may hire, for example, the company may hire another employee later, right? In the future with the same name of the current employees. So choosing something like employee name is not a good, for example, choice for primary key. But employee number, we are sure that each employee that joined the company will have a unique number, and that's why that is a good primary key. And in general, we try to assign the numeric columns for consider the numeric attributes for primary key integer numeric values, because text values like character values are not as fast as the integer ones later, because always the primary key is indexed, and I'm going to talk about index in the future in this course. And that helps, for example, speed up the queries. And if you are using, for example, integer values for that, that is much more efficient compared to like a textual values. So these are the, like at least these two reasons are, I think, justifying why we are using, for example, employee number, student number, product ID as the primary key. Now, what is a candidate key? So candidate key is any key that can uniquely identify its role, right? So similar to primary key, but may or may not be may or may not become your primary key. For example, in a table like this, you have employee number, employee name, department number, and so on. And as you see, both employee number and employee name, at least in this example, they both can uniquely identify each row, because we do not have two employees with the same name, and we do not have two employees with the same number. So we can say they are both candidate keys, which means they are our candidates to become the key or primary key. But out of all the possible candidate keys that we have, we always choose only one that is the most suitable one as our primary key. So each table can have several candidate keys, right? But out of like these several candidate keys, only one of them will become your primary key. Or we can say each table has a unique, only one primary key. So let's say we have also employee, I don't know, email here. So if each if each employee has a unique email, let's say at York University you are using, for example, York emails, right? Let's say it's the same for employees, and each employee can only have one unique email. Can we use email as primary key? Okay, email is a candidate key, but it's not a good choice for primary key. Why is that? Why email is not a good choice for primary key? Yes, first reason, because it's a string. It is not like integer that is fast and more efficient for later, for example, querying and also for indexing. Second, in this case, we cannot have two employees with the same email. So the only reason at this point is this. But in general, another reason is that sometimes people may change their email, right? So yeah, exactly. Email are not immutable. So people may change their emails later. So this is not a good one. But people cannot change their employee number. You cannot change your student number. So these are always remains the same. And this is another reason. And so let's move on to the next. Now here we have example of relational and non-relational tables. So on the top you see a table that is a relational table, or we call it a relation. That's why I said each relation is a table, but not every table is a relation. For example, the table on the bottom, this table is not a relational table, and it is not a relation. This is just a table, not a relation. So can anyone explain what is the problem with the second, or the table in the bottom, that is not a relational table? What's the problem with this? Employee information. What's wrong with employee info? Yeah, we have multiple columns with the same name. Primary key is duplicated. Exactly. Employee ID should be unique. Last column has different data types. Exactly. No primary key. Yep. Two rows have the same values. Yep. Each row must be unique be a relation, employee ID duplicated. Exactly. So all of them are correct. So as you see here, the table in the bottom has several issues. So first of all, if you look at the employee ID, you see that this is repeated. We said, yeah, do you have a question?
Okay. There's a message that she replied and then.
I'm sorry, do you have a question? Okay, so I think that was an accident.
We have class right now, but for some reason I moved online because of squall. Sorry.
Sorry, so I'm not sure who is talking now, but can you please mute your mic? If you have a question, of course not, but if you don't have any question, can you please mute? Okay, that's fine. So it happens, online classes. So we were talking about this table in the bottom, which is not a relational table, and there are several issues here. First of all, some rows are repeated. For example, row 1 or record 1 and record 3, they are basically the same thing, right? So this is repeated. We cannot have duplicated rows. Another issue, we have the same column names in column 2 and 3, right? So column 3 is actually representing, for example, gender, but it's using the same name as the second column. Now, another issue, employee phone number. Employee phone number for employee ID 0004, as you see in the fourth row, we stored multiple values in one cell, which is not correct, right? So we also mentioned that we cannot have this. So this is one problem. You cannot store two values in one cell. Another problem is the data type in this column. So as you see, some of them are date, but what is this one? A long time ago. It's just text, right? This is not a date. And here is another problem, two columns with the same name, so we cannot have that. And another issue is that the primary key is not unique. Or basically we do not have any primary key here, right? Because these are not unique and we have duplicated rows. And now here is example of relation with rows and columns appearing in a different order. Now, looking at these, are both tables relational tables? Are they both relations? So my question is, are both tables relation? Yes, they are basically the same tables, only the order of rows and columns are different. And we said that is not important, right? Now, there is a question, why does the phone number have to be unique value? Can't people share the same phone number? You mean people having two people having the same phone number? Like in general, consider, for example, yeah, that could be the same home phone number, and we didn't say that home phone number can is unique. Did I mention anywhere that this is unique? So people, yeah, in a family can share the same phone number, home phone number. For mobile phone, it's like in general, like if you're talking about employee, for example, table or a student table, right? They all have a unique phone number. So that is still a unique, could be a candidate key, but again, not a good one because of the same reason. People may change their phone number, right? And that is not a reliable one to become a primary key. And so, do you have more questions? Do you have any question? Does every table need to have primary key or at least connect or relate to a table with a primary key? Okay, The first part of your question, does every table need to have primary key? Yes, every relational table or every relation should have a primary key because we should be able to uniquely identify each row. And then connect to a table with a primary key. We do not connect tables using primary key. We connect them using foreign keys. And but I could understand maybe you mean because foreign key is also a primary key in another table. In that it is a common attribute. We connect table using a common attribute. It may even not be a foreign key, and I will cover that example as well later. What if an entire row is repeated once? Will it still be a relational table? No, we cannot have repeated rows. That's redundant, right? We don't have that. Now, there are some terminologies: candidate keys, primary key, composite primary key, surrogate key, and foreign key. And I'm going to explain these now. So candidate keys, as I explained before, they can uniquely, that's just a column or attribute that can uniquely identify a role. For example, full name or phone number, right? And phone number, because one of your friend mentioned about home phone number, that for example family members can share the same phone number. That's an exception, right? But in general, when you're talking about phone number in employee, student, customer information, uh, each customer, for example, enter a unique phone number, right? And now, if phone number is unique in your table, if phone number is unique, that's a candidate key. But does it qualify it for like a primary key? No, because of the reason I just mentioned. Phone numbers may change later, right? Full name may be unique now. Maybe you have a customer table and no two customers have the same name, and then you decide, okay, let's have, for example, customer first name or last name or full name as the primary key. Again, for the reasons I mentioned, that's not a good option because first, we prefer columns that are integer numerical values, contain numerical values. Second, we prefer columns as primary key that do not change later, like phone number, right? Or there is no chance of that column being repeated later. So even if we don't have two customers or two students with the same name right now, it doesn't guarantee that we will not have a customer or employee or a student with the same name later. And so these are only candidate keys because currently they can uniquely identify a row. Now, primary key is one of those candidate keys that actually become your primary key, right? And it can uniquely identify each row as like obviously. Concatenated key or composite primary key. Recall when I talked about enrollment table, which was when I was drawing the ER model for the student registration. I mentioned we have, for example, a student and a course, and let me show you again. So we said we have, for example, a student, right? And then we have, for example, course here. And because they have many-to-many relationships, so we have associative entity enrollment, right? Now, so here a student has a student ID, right? Is it only so difficult for me to write, or is it for everyone here? Like student ID, a student, for example, first name, last name, and so on. Let's say it has more attribute. And we said a student ID or a student number is unique identifier for a student. And then we had this relation here and also this relation here, which is one-to-many, one-to-many, right? Because a student and course have many-to-many relationship. Each student can take multiple courses. Each course can have multiple students. So we added enrollment. Now each student can enroll in several courses, so it can have several enrollments, right? It can also have 0 enrollments, so this is optional, right? And then each enrollment belongs to one and only one student, right? That is, if we have enrollment, in this part, this is mandatory, right? Because if there is an enrollment, so there should be a student. And also each enrollment is representing only a specific student. So if you have an enrollment table here with, for example, a student ID, course ID, and some other attributes like grade and so on. So here we said each student can, like each of like these rows here in the enrollment table representing what each row here represents, each row in the enrollment table. Okay, so does each row in the enrollment represent a unique student? So let's say student 1 take course, I don't know, 3421. And then a student ID 1 take another course, 4412. Because we said one student can take multiple courses. We also mentioned that we cannot store values like multiple values in one cell. So we cannot have a student ID 1 and then separate all the courses that a student 1 is taken, like just by separating by comma, right? We cannot do that. So if we store them in different rows, then we have this problem that a student ID is repeated. But that is not actually a problem in the enrollment table. In the student table, that was a problem, right? Because a student table, in the student table, a student number or a student ID should be unique and cannot be repeated. But this is an enrollment table, right? This is an enrollment table. And in the enrollment table, a student ID can be repeated because each row in the enrollment table, this is enrollment table, each row is representing a unique enrollment, right? This is a unique enrollment. So this is representing one enrollment, this is representing another enrollment, and so on, right? Now, should a student ID be unique? No, because each student can have multiple courses. And does course ID should be unique? Is course ID unique? No. Again, with the same course, 4412, we can have multiple students enrolled in that course, right? We can have the second student enrolled in this course and maybe hundreds of students enrolled in this course, right? So none of these alone are unique, but together they can be unique, right? I like actually different colors here. And so this is your composite primary key. Now I made a real mess here. Just I have to clean this. So this is your composite primary key or concatenated key. So when we talk about that, this is what we mean. Now I'm just to make it more clean, I'm removing this part. Now, so I said we have a student, enrollment, and then course. So this is a relationship between these two, and let me also complete this with course. So from the other side, can you help me with this? The relationship between enrollment and course. One to many, right? So each course can have, for example, one or more enrollment. Can we have a course with 0 enrollment? It depends on your assumption, right? So if you assume that you can have a course that no student enrolled in that course yet, so in that case, that will be optional. So if that's the case, you say, okay, each course can have 0 or, for example, multiple enrollments. And also, each enrollment belongs to only one and only one course, right? Because if you have an enrollment, it means that it belongs to just a specific course. Now, this was about the relationship between like these. Now, about back to the composite primary key. Why does enrollment has a composite primary key? So how you have to like to answer that, you have to first answer this. How do you link tables together? So if you have a student table and enrollment table, how do you link these two tables? Hello? we link them using a student ID, right? Exactly. So now, for example, here, because we said we cannot add the course ID here, right? So we cannot have a student table where we have a student ID and see list of the courses, right? Because we cannot have multiple values in one cell. Now, we know that. We also know that we cannot add, for example, a student ID to the course table, right? We cannot add a student ID to the course table. So this is also not possible. And that is why we added this associative entity, enrollment, right? And in general, when you link two tables together, you use a common attribute, which is most of the time your foreign key. And what is a foreign key? Foreign key is just like your primary key that appears in another table. For instance, here, when you connect a student to enrollment, right? What are the columns in the enrollment? You have a student ID, you have course ID, right? So you have a student ID here, added as a foreign key. Why? Because you linked this table to this label, and always when you link, you have a common attribute here. What is that common attribute? The primary key of this table appearing as foreign key in the other table. In other words, primary key of a student table appearing as foreign key in the enrollment table. Now, the same thing happens here. So when you connect the course table to the enrollment table, the primary key of the course table, which is the course ID, so the primary key is course ID, right? The primary key appears as a foreign key here again. Course ID will be foreign key here. Now, we don't show foreign keys with underline. The reason I'm doing underline here is because these two together can form a primary key. So this is your primary key, and we call this composite primary key. So the most important thing, like a recap of what I covered, is that when you are linking two tables together, right? For example, let's say when you link a student table to the enrollment table, you always have to add the primary key as a foreign key to the other table. So in this case, when you are connecting, for example, a student to enrollment, a student ID will be added as a foreign key to the enrollment table. Now, to just make this even more clear, imagine you had a student and course, and you keep them as just many-to-many relationships. So do not use any associative entity. Now, if that's the case, you have something like this, right? You have a student here, and you have course, right? And then there is a many-to-many relationship here. Each student can enroll in 0 or more courses. Each course can have 1 or more students enrolled in that course, if this is my assumption. You can also assume that this is optional, doesn't matter. So this is a many-to-many relationship. If you keep it this way, and let's say you have a student ID here, and then course ID here, and then course ID here. So how do you represent this in terms of tables? Can you tell me, let's say your conceptual model is as simple as this. You only have two entities. One entity is the student, the other entity is course, and you keep it as many-to-many relationship. Let's say you don't use associative entity. How do you store this in terms of tables? Multiple course columns. So let's say you have a student ID in the student table, and then a student first name and last name. This is your student table, right? So when you want to translate this ER model to relational schema, which is the content of today's class, we want to convert this into relational schema. So each entity will become a table. How many entities do we have here? Two entities, right? A student and course. So you will have two tables, sorry. So one table is the student table here. The other table is the course table with course ID, course name, and so on. You also have to identify the attributes of each table, right? Or columns of each table. Columns in each table, as I showed here, just representing the attributes. So for example, if a student table has a student ID and first name and last name and so on, right? So you represent each of like these attributes. You represent each of these attributes as a separate column here. Same thing for the course table. Now, how do we show the link between two entities? How do we show the link between these two entities? So in the conceptual design, in the ER model, you can easily show that with this line, right? And you show the relation with this oval, right? With this diamond. How do you show this in your relational schema, which contains these tables? How do you link these two tables? No, not exactly, because for example, let's say if your relationship was between, for example, course and instructor, and there is a one-to-many relationship, okay? So let's say this is instructor, and there is a one-to-many relationship here, right? So each instructor can teach one or more courses, and each course can be taught by one and only one instructor. Now, in this case, you also have an instructor table, right? And the columns will be any attribute that you have here. For example, instructor ID, or for example, instructor name, and so on. And so on. So here you have instructor ID, name, and so on. So we need to break them many to many. Okay, so maybe I have to repeat my question. So my question is not about the many to many relationship between a student and course. My question is in general, how we represent links or connections that we have in the ER model in relational schema. For example, if I ask you how do we represent entities in relational schema, what is your answer? A table, exactly. So each entity will be a table. Now, looking at this simple ER that I have here, how many entities do we have? 3. So we will have 3 tables, as you see here, here, and here, right? So we have 3 tables. Now, what are the attributes? The columns of each table. For example, a student entity has, let's say, 3 attributes: a student ID, first name, last name. So these will be the columns of your table. Now my question is, how do we represent these links or these connections between tables? How can we show that? Foreign keys. Thank you, Michael. Foreign keys. So we show them using the foreign keys. Now, how does that happen? So let's say you have, for example, course and instructor, right? So in the course table, we have course ID, course name, and so on. And in the instructor, the same thing. We have, for example, instructor ID, instructor name, and so on. Now, how do we add foreign key? Foreign key is basically a primary key in another table. So we have 2 options. What is the primary key in the course table? Course ID, right? What is the primary key in the instructor table? Instructor ID. You have 2 options. One option is adding instructor ID to the course table. So we can add instructor ID to the course table as the foreign key. Instructor ID, let's say. Or we can add course ID. We can add course ID as the foreign key to the instructor table. Now, which one is correct and why? Instructor key, adding instructor ID, you mean instructor ID to the course. Exactly, that is the correct one. Why? Because each course has only one instructor. So adding instructor ID to the course table doesn't cause any issues, right? So we have, let's say, course 3421, right? And then this is the database course. And what is the instructor? Let's say Mona, right? And my ID, let's say, is 1. And so if in our assumption, which is represented in my model, right, I said in my assumption each course can only have 1 instructor, right? And if that's the case, there is no problem here. So we can add instructor ID as a foreign key to the course table. So this will be your foreign key then. Now, should foreign key be unique? So, okay, yes, okay, that is wrong. That is not correct. Instructor ID or foreign key should not be unique. Why? Okay, so let's say in the course table, we have course 3421 and instructor is Mona with instructor ID 1, right? Let's say instructor ID 1 is Mona and instructor ID 2, I don't know, is Alex. Instructor ID 3 is Godfrey, and so on. Now, when we add instructor ID to the course table, is each course ID in the course table unique? Yes. So we have only one, for example, 3421 here. And then the next is, for example, another course, let's say 4412. Now, I'm teaching also, this is data mining course, right? And I'm also teaching data mining course. So the same instructor, as you see, same instructor is teaching this different courses, right? So instructor ID, which is the foreign key, can be repeated. So we don't have any like limitation for that. And is there any problem? So can I call this table a relation? Is it a relational table now? Yes, it is. Because we have a unique primary key, right? The table has a clear primary key, which is course ID. Each row is unique, right? So here, each row is unique. This is a unique row, and this is a unique row. It doesn't matter if instructor ID is repeated, because instructor ID is just a foreign key. It's not a primary key. Instructor ID in the instructor table should not be repeated, but here, it is just a foreign key. In the instructor table, instructor ID is the primary key, so it cannot be repeated. Now, my second question, can we add course ID to the instructor table? No, because then for each instructor can teach multiple courses. For example, this is Mona teaching database and data mining. And then if I list database and data mining here, then this is not a relation anymore, right? If I add, for example, the course ID 1 and course ID 2 here, right? This is then not a relational table. So hopefully foreign key is now clear. So foreign key is just basically a primary key in another table. And oh, this doesn't. Okay, so it's stuck on my page, sorry. Foreign key, do you have any question about foreign key and primary key? How would you add what courses are taught by each prof if you can't use course ID? This we already did. So we added the instructor ID to the course table. So later, when you learn SQL queries, you can query the same table, the same course table, not only to see who is the instructor for specific courses, but also to see, for example, which courses each instructor is teaching, because both these information exist in the course table, right? In the course table, we have course ID, course name, instructor ID. And then if you also want to get the instructor name, because you only added instructor ID as foreign key to the course table, then you can join the course and instructor table together to also retrieve other information about the instructor, like instructor name and so on. So how can I get rid of this? This is not going anywhere. Okay, just give me a second. Let me stop share and start again to see if because this I cannot close the chat anymore. Okay, good. So surrogate keys. Another type of key is a primary key that is automatically generated by your DBMS to identify a row that can uniquely identify each row in your table. And so this is a system generated number. So sometimes in your tables you do not have a natural primary key like a student number, employee number, product number, and so on. And this happens. If that was the case, we often look for composite primary key. For example, enrollment table, right? In the enrollment table, we have course ID, student ID, and grade. So course ID alone cannot be primary key because courses in the enrollment table can be repeated, right? And then a student ID in the enrollment table cannot be primary key as well because students can be repeated too, right? Because for each course we have multiple students enrolled. So neither course ID nor a student ID in the enrollment table cannot serve as primary key, but together they can be your composite primary key because we do not have, for example, multiple student ID, course ID. So if you have, for example, course ID 3421 and then a student, for example, ID something, right? This is unique. And this is considering if your assumption is that each student can enroll in each course only once. You can make it more complex and assume that, for example, what if each student enrolled in each course twice? What if, for example, you enroll in fall and again, for example, drop, or for whatever reason you enroll again in winter? In that case, you also add the semester, right? Fall, winter, etc. And then your composite primary key can contain 3 columns: course ID, student ID, and also the semester. Now, sometimes you have to select 4, 5, or even more, for example, columns to represent your primary composite primary key, which doesn't make sense and it's not efficient. So you add a surrogate key. And surrogate keys are also widely used in data warehouses that I'm going to cover later in this course. So right now you only need to know that if you cannot have a natural primary key or like a reasonable composite primary key, then you can use surrogate keys. Now here is just an example. So here you see an entity with a unique composite attribute which is mapped into a relation. So for example, let's say you have classroom as an entity, and classroom has two attributes like classroom ID and number of seats, and classroom ID contains building and room number. And so if I want to explain how we represent that in terms of relational schema, relational tables. This is how you show them. So your classroom entity will be your classroom table, and then each attribute will be your column of your tables. Now for classroom ID, because it's composed of 2 other attributes, you don't need to repeat classroom ID here because it is 2 different attributes, right? So you only show building and room number. And I think one of you already asked this question last session, that if we have composite attribute, how do we represent them in the relational tables? This is how you show them. You don't show classroom ID, you only show the components of classroom ID. So when you want to convert your ER model to relational tables, you create one table for each entity. So we said each entity will be translated to a table, right? And then the attributes of your entity will be the columns of your tables. Unique identifier of your entity will be your primary key. For example, if you have entity student with a student number as unique identifier, then you will have a student table with a student ID as primary key. And then introducing foreign key into the many side to represent one-to-many. What do we mean by this? Introducing foreign key into the many side. let me just answer this question. Can a student ID be a foreign key for another table? Of course it can be. Yeah. If a student ID appear in any other table, it will be foreign key. It can be a foreign key in many tables, right? Not only one. For example, if you use a student ID in the, I don't know, it doesn't make sense to have it in the instructor table because we always add foreign keys to the many side. But if you use a student ID in another table, then it is a foreign key. Is the classroom table non-relational since there is no primary key? Let me see. Classroom table. We have primary key. We have a composite primary key. We have building and room number as primary key. So neither building nor room number alone cannot uniquely identify each row because we have repeated building name and we have repeated room number. But together, if you look at them together, they can uniquely identify each row, right? This is unique, right? Each of these. So, for example, you only have one Hauser 110 and one Hauser 210, right? So these are not repeated, these are unique. And that is why this is your composite primary key. Is this clear? Okay. And how would we represent multi-valued attributes in tables, or is this getting covered later? I'm covering this later. There are several ways to show that. Sometimes we show them even as a separate entity, but I'm going to provide examples for that later as well. So for now, let me again delete this. Now, what do I mean by introducing foreign key into the many side of the relationship? I just simply mean if you have a relationship like, for example, instructor and the course that I mentioned, right? So I mentioned you may have a student, course, you may have a course, and you may have instructor. And let's keep it simple. That is, assume that each instructor can teach, for example, 0 or more courses, or 1 or more courses, depending on your assumption, and each course is taught by only one instructor. I know that at York University, each course can be taught by different instructors, but most of the time that is not the course itself, they are the course sections, right? So then that would be the relationship between the course section entity and the instructors, right? But even if for the same course or the same section you think that they can have different instructors, that's a different design. But for now, I'm keeping it simple, assuming that each course can be taught by only one instructor. Now, what is the many side of the relationship here? And this is course ID, which is primary key here, and this is instructor ID, which is the primary key here. So now, what is the many side of the relationship here? Is this instructor or course? Course. So this is the many side of the relationship. And we always add foreign key to the many side. So if you are thinking, if you are, for example, converting your, if you are converting this ER model to relational schema, and you say, okay, I have course table with course ID and course information, and then I also have, for example, this is course ID, course name, and so on. This is your course table. And then you also have instructor table, which is instructor ID, and so on. Oh, this is so difficult. So now the question was adding either course ID as foreign key to the instructor table or adding instructor ID as the foreign key to the course table. Which one is the correct one? Adding instructor ID to the course table, right? So we said we add instructor ID to the course table as the foreign key. And this is because this is the many side of your relationship. And you don't even need to memorize this because I already explained it in detail with the example. I draw the tables for you, right? And showed that if you are adding course ID as the foreign key to the instructor, if you add course ID here, then for each instructor, let's say instructor Mona, right? Then we have multiple courses that this instructor is teaching, and you cannot show that. This is not correct, right? But you can add instructor ID to the course table, and this is because each course each course is only taught by one instructor. Okay, so we are almost done. Let me see what is remained here. Okay. And for one-to-one relationship, a unique foreign key can be put in either table. For many-to-many relationship, we already learned that we add associative entity, which convert that into two one-to-many relationship, right? And then for each one-to-many relationship, then you can add the foreign key to the many side. And that is why each composite entity or each associative entity have two foreign keys, right? Why do each composite entity have two foreign keys? Can anyone answer this question? Assume you can consider, for example, enrollment. Enrollment is an associative entity between course and a student, right? Yeah, because they are connected to two, they are always connected to two tables, right? With many-to-many relationship, they are breaking that many-to-many relationship into two one-to-many. So, for example, enrollment is connected to the course table, therefore, course ID will be added to the many side, which is enrollment, right? So course ID will be added as a foreign key to the enrollment table, so far one foreign key. Enrollment is also connected to a student table, so a student ID will also be added as foreign key to the enrollment. So this is now two foreign keys, right? Because it's connected to two tables. And so you see this example here, and I already explained it. So I mentioned why we cannot put employee ID as foreign key in the department table. So if you see here, I want to translate this ER model to relational schema, which you see here, and then our tables later, right? So each entity will be a separate table, right? As you see here, this is your relational schema, and these are your actual tables. And each attribute will be the columns of your tables. Now, you see that we added department ID, which is the primary key in the department table, as a foreign key in the employee table. Now, the question is why we cannot add employee ID to the department table? For the same reason that I just mentioned, right? For the same reason, because we always add the foreign key to the many side of the relationship. And because if you add employee ID here, in each department, we have many employees working in that department, right? Maybe we have hundreds of employees working in department ID 1. We cannot add hundreds of employees here. And so you either have to separate them by commas, which is not atomic, and then it is not a relation. If you are also storing them in multiple rows, then it breaks your primary key rule, right? Then you have to repeat the department ID. So you cannot add employee ID as the foreign key here, but you can add department ID as the foreign key to the employee table, because each employee, our assumption is that each employee is working in a unique department. And here is just one more example with many-to-many relationship and how we convert that. So again, as you see, each entity is converted to a separate table. Attributes are the columns of your tables, and then you added, for example, a student ID to the many side of the relationship, which is this one, your associative entity. Associative entities, as I mentioned, always have two foreign keys because they are connected to two tables. So they get the primary key of each table as foreign key in their own table, right? So a student ID in belongs to table is foreign key. Organization ID alone is also foreign key. Together, your primary key is student ID and organization ID. So together they form the composite primary key. And yeah, these are just more examples and showing how you can use ERD plus to actually convert your ER model to relational schema. This is more notes on how related to the questions that one of you asked earlier, how we can represent multi-valued attributes. I'm going to explain further next session with more examples. So we covered the main concept of like relational schema today. Yeah, and these are just more examples that I'm going to cover next session. Do you have any question? We are going to have also, I have a Kahoot game, I think at the beginning of the next lecture. Do you have any questions? Okay, so if you have any question about the lecture right now, and then I can answer your direct questions later. Do you have any questions about the lecture? Okay, do you have any question about your group project? Are the instructions for the project proposal posted? It isn't like a very complex things which require instruction. I can post a sample for you because in your proposal you only have to provide one page, and in that one page you start explaining, for example, what is the background of the company. Let's say you're assigned, for example, to Uber Eats, right? So you provide a brief description of the Uber Eats company and its background, and then you provide main functionalities that are available on their application and website, right? And then when you do that, after that, you have to also provide at least 1-2 paragraph explaining the scope and boundaries in your project. We talked about the scope and boundaries in the first lecture, so you can refer to the introduction slides for that. You can mention, for example, these are, for example, the functionalities available, but for example, we limit our scope to this, and this, right? Because of, for example, the time limitations, because of the technical limitations, and so on. So you have to clearly specify the scope and boundaries in your project. And that's it. That's just to give you a chance to get some easy marks. The first assignment is not posted yet because I realized I have to adjust a few things. I wanted to update a few things before posting it. Lecture recordings, I'm going to post them on eClass. You can also find them on my YouTube channel. So on YouTube, I already posted the recordings of my previous semesters. This semester I couldn't find time to post the recordings yet, but I will do. If you are just in rush, you can still use the recordings of previous lectures. But I will post them soon, and I will post an announcement to let you know. No worries. Thank you for coming to class today, and sorry for the late notice. Could we come to you for feedback on the project proposal? Of course you can. Does the proposal include business rules like relationship and entities? No, in your proposal you don't need to provide business rules, and that is part of your assignment 1 and also your group project, but not proposal. Proposal is just one page explaining the background of the company and company description, what are the objectives, what are the functionalities available there, and what are the scope and boundaries in your project. Have a great day, everyone. Have a great day. Okay, do you still have questions? If not, I'm going to just end the meeting. Okay, good day, everyone. Will I be able to join the random group? Yes, you can. Yep, I'm going to. Is the deadline to join the groups ended, finished? Yeah, we submit everything on eClass for this course. So if you are still able to join the groups, so for your group project, the deadline is January 18, which was last night, so you are not able anymore to join this. So I'm going to add one more day in case you need time to join the groups. There was something to add this. Okay, I'm doing this later. I'm going to give you one more day until the end of tonight if you haven't still joined any groups yet. No problem. We submit class. Okay, is there any more questions? Okay, then see you on Wednesday.